Hello everyone. The system we will be analyzing today is a type MM1, considering and assuming that there's only one server available for this process. So we basically analyze as the location embarcadero, specifically the menú del día. So we analyze hours from 11 to 12 and 12 to 1 in a Tuesday, a Wednesday, and a Friday. We take into account two main important factors. The first important factor was the number of people queuing every 1 hour interval. So the first hour was from 11 to 12 in the Tuesday, that was 124 people, and then to 12 to 1 that was 157. Then on Wednesday, 93 from 11 to 12 and 190 from 12 to 1. And finally, it was on Friday, 11 to 12, 82 people, and from 12 to 1, 161 people. And the second factor was the average time from queue start to payment. So on Tuesday, from 11 to 12 was 4.13 minutes, from 12 to 1 was 2.48 minutes, on Wednesday 1.1 minutes, on 11 to 12, 12 to 1 3.98 minutes, and on Friday 1.18 minutes, on 11 to 12, and 12 to 1 1.65 minutes.
Here are the calculations we used to facilitate our analysis. Firstly, we calculated lambda by dividing the total number of people that arrived in the hour divided by 60. For WS, we took the average total time that the customer takes in the system. And then for LS, we took Little's law, which states that LS equals to WS times lambda. To calculate mu, which is the service rate, we used mu equals lambda over LS plus lambda. And to calculate rho, which is the use of the system, we did lambda over mu.
Okay, so now we're going to analyze the system behavior with the data that we collected. So upon examining this data, we observed different variations, such as variation in arrival rates, variations in service capacity, and variations in system utilization across obviously different time slots and days. And we found some key information. That first was peak utilization, that the peak utilization, the highest was in day 2, from the hour of 12 to 1 p.m. and it had a row of 92.65%. That show us a period of high demand. So the second key find was that the lowest system utilization was on day 3 from 12 to 1 p.m. at 61.77. It shows us that there is a possible underutilization of resources. And finally, the longest customer time in the system was on day 2 from 12 to 1 as well, at 3.9 minutes, coinciding with the highest arrival rate.
So now let's talk about the bottleneck. A bottleneck occurs when the system utilization is very high and service capacity is near its limit. Based on the analyzed data, we can conclude the following. The primary bottleneck occurs on day 2 from 12 to 1 p.m., where the system utilization reaches 92.65%, indicating a workload close to its capacity limits. Also, the average time in the system is 3.9 minutes. It's the highest recorded, potentially also causing delays. And finally, the average number of customers in the system is 12, and it reflects a significant accumulation of waiting customers. This data showed that the system is operating near its maximum capacity during this time slot, which may impact efficiency and customer experience. To improve this process, it is necessary to implement strategies that reduce congestion and balance, and also balance the system's workload.
Our process of improvements, we recommend it to improve efficiency, so we should increase our service rate during the peak periods. Also, taking account that our mu is of 3.4, we can increase it to 3.7 per minute, so we could reduce this average waiting time by optimizing all this staff allocation during peak times. Hiring an additional server of increasing efficiency can help. Also, if our process of time we can reduce it to 4 minutes to 3, the total system congestion will decrease and redistribute demand, encouraging customers to visit during lower periods. Also, our positive initiatives could be help this shift demand, and we can conclude that by increasing the service rate, we can optimize demand and distribution system, and we can reduce all this congestion and improve efficiency in these peak hours.